Music theory, OneNote presentation, using the major scale formula to construct the 7-note major scale and then compare and contrast the major scale in all 12 keys. So get ready and some coffee, because although we're playing with just one note, it's a beautiful note. You're not required to, but if you have access to it and would like to follow along, we're currently in the OneNote file of the modal node system, MNS presentation 1125 Excel major scale formula. One of only 4 presentations thus far, but we plan on adding plenty more shortly. Also noting, in this presentation, we can spend all of our time just analyzing the tables from a theory perspective. However, we have another presentation by the same number and name as shown here, where we actually build these tables within Excel, practicing our Excel skills and visualizing tables. 2 skills I think are highly important to anybody that wants to spend a significant amount of time with music. So what we're going to do now is look at the major scale formula. We'll be breaking that major scale formula out into the 12, or building it off of the 12 notes in the musical alphabet. So the best way to do that then is to start with the bottom line of the musical alphabet. Now remember that a lot of times if you learned on the piano, you're still going to see this as being a little bit backwards, because most likely you learned the 7 notes, the scale of the key of C in particular, before you learned the 12 notes, because that's a little bit easier to play. You can play something in key. And that's kind of, once again, how we learn things historically, how things were put together. But it makes more sense from an analytical perspective to say, hey, look, what we have now is we have an octave, and we want even units within the octave. So now we've broken out the octave systematically into an equal 12-unit span instead of just the 7 units. Remember, the 7 units were created before they had the 12 units. That's why it happened. But now we have the 12 units. Therefore, when we think about building the major scale formula, it makes sense to first think about the baseline. If you're doing a computer program, or similarly, same thing, mapping this out in your mind, what are you going to have as your baseline, your building blocks, your bricks? You're not going to have the 7 notes. You're going to have the 12 notes, right? 12 notes. That's the baseline. So we've numbered them here. So we have 1 through 12 so that we can use some simple math, highly useful, not arguing that we should remove the letters entirely. I'm saying that you should know both, because that allows you to do simple math, which becomes really important, as we will see when we get to intervals. I'm also going to abbreviate the sharps and flats, not saying sharp or flat. I'm just going to call it an AB. And people could get mad at me for spelling things improperly with like an AB instead of the proper sharp or flat. Okay, that's fine. But I want to, when we get into spelling, which isn't my strong point even in English, right? Then we can talk more about, the intricacies of spelling. For right now, I want to make it as easy to see the actual pitch that we're talking about. Easiest to see is by number. And then when we have the letter, I'm going to put the AB for the sharp or flat. Okay, and then I'm going to combine them together over here. I'm going to show that one shortly. All right, so then what we want to do is look at the formula. Now, we talked about how to derive the formula. Let me, in a prior presentation, but let me give a quick recap on that. Remember that what happened is you've got like Pythagoras before they had the 12 notes, and they derived the formula, just so you have some context, so it's not arbitrary. I feel like the fact that it seems arbitrary makes this argument of it's all relative. This is just a Western music thing, and it's all relative, but it's not really. It's kind of based on math. So there is a mix between how relative it is culturally and how much it is based on math. So notice what he did is he stuck fifths on each other. So if we start on the C, and he did it with ratios, but let's just think about it as though we have the 12 notes and count out fifths. We'll talk about what a fifth means measure-wise in a 12-note system later, but for right now, it's 7 notes apart. 7 half steps apart is a perfect fifth. So if you stack those on top of each other, going from C, you go 1, 2, 3, 4, 5, 6, 7, you get to a G. If I go again, 1, 2, 3, 4, 5, notice that this goes up to another octave. I'm cool with that. I'm going up an octave, but also around in a circle because they repeat. 6, 7, I get to a D. 1, 2, 3, 4, 5, 6, 7, I get to an A. 1, 2, 3, 4, 5, 6, 7, I get to an E. 1, 2, 3, 4, 5, 6, 7, I get to a B. And then if I do it again, I actually get to an F sharp, which is kind of fudging it, right? So it didn't work perfectly because the math is a little wonky. You have to put a plug in there to make it work. So they adjusted everything and whatnot to kind of tweak it so we get the F instead of the F sharp. And those are the ones, so then if you take those notes and squish them in one octave, putting them order of stepping stones upwise, that's where we get our scale, which first was the C major scale, right? So then they put in the 12 equal spacing. And if you put in the 12 equal spacing, then we note, how do we get those 7 notes with a 12 equal spacing? Well, you use the formula called whole, whole, half, whole, 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 half. That's going to be our formula. So now that I have all these notes, what am I going to do now? I'm not going to rederive the thing. I'm going to say now I have all 12 notes, and I'm just going to note that this formula gives us the 7 notes, not only in the key of C, but off of any note that we start on, any of the 12 notes that we decided to break the octave into, any of those 12 notes that I start on. If I apply the formula, we'll get 7 notes that we can call a collection of notes, which most people call like a scale, right? But the scale really, I think, is supposed to be in ascending order. I think most people define a scale as the tonic, right? So you're playing something, even if it's not in ascending order, you're talking that's the tonic of it, the center point, then you call that a scale. But I think technically you're supposed to be playing in ascending order. That's going to be a scale. Otherwise, it's a collection of notes, whatever. So we're going to go, that's kind of important because it does help to be more specific. I just feel like a lot of people aren't as specific with that terminology, so it's hard to be specific with it. Anyway, so if I do that, notice if I skip one, realize that the distance between 2 notes, the simplest distance or our base distance, is a half step. So we broke the octave into 12 steps. They're all equal half steps. So now we've got 12 notes that we have a half step up. I named the first note 1. Programmers would have liked to named it 0, right, if it was on A. But I think it's easier to remember that the A is the 1, right? So that's why I put a 1 there. And then it's going to be half steps. Now, quick note on the naming convention. We're only going to be working with whole steps and half steps right now. Notice that the whole step and half step terminology does not have a relative position in the scale implied in the name. But when we go something past a whole step, then it does. So in other words, if I go from the C to the C sharp, that's a half step. I could also call it relative to a scale degree. I can call it a 1 note away. I would call it a 1 note away. People don't usually say 1 note away. I say it to be more specific, 1 note away minor second. The second represents the relative position on a scale degree. That's where we're going to run into problems. We'll get into that later. Notice that when I talk about wholes and half steps, I don't have to do that because I can just say it's a half step, and that doesn't have a relative position to a scale degree. If I go 2 notes, we call that a whole step. So you skip a note, you get a whole step. Most of the steps in our formula are whole steps, which makes intuitive sense because a whole step gives you a nice stepping motion upwards. So you get a stair step kind of sound, but it's not too close, so it's too muddied. So it's not too far away, it's not too close, so it makes sense that we break the octave into 12, and then most of the steps we take are whole steps, which makes it not too muddy. It's pretty good distance between, the intervals. So if I go a whole step here, we call that a whole step, then notice that doesn't also have a name that's going to be confused with a scale degree, but we could also we generally call it, when we use the scale degree term, a two note away major second. So, right, and if I say it's a major second, that major second means it's second to a scale degree. That's going to cause us problems when we're trying to measure from a modal center. So just keep that in mind. We'll get there later. And then if I go 3 up, we're not going to deal with that right now, but just realize when you go 3 up, there's no term to go up 3 except that you went up 3 half steps. Otherwise, you have to say it's a minor third. If I go up 4, I got to say it's a minor fourth. I got to say it's a major third. The third doesn't stand for the number of half steps. It stands for the relative scale degree. So we'll get into that later. I just want to introduce this measurement idea because it's really a little wonky. It causes a lot of kind of issues with trying to see what exactly do you mean by that. So we'll get into that later. Right now, we're just dealing with wholes and half steps, and there is our formula. So whole step, half step, whole step, and then if I keep going, you get a whole step, whole step, whole step. It's going up through the octave, and then half step back home. If I get to this A, you can think of it as a circle going around to this A, and then back home this way as well. So remember, you can think of it as a line, linear, or you can think of it as a circle. Now, if I actually define this how a computer would see it, which I think is useful because simple math is useful, we would say, what is a whole step? It's 2 base note steps. It's 2 half steps. Our base measurement is 1 half step. A whole step represents 2 half steps. So the formula should be 2 in distance, 2. So remember, this is going to be wonky when we go forward, because notice when I measure something, I measure from that point and say it's 2 steps up, 1, 2. I don't want to say I'm going to make this the 1 and that's the third of the 1. That's what we're going to end up doing later. That's going to get messy. From a programming perspective, that's where you get this off by 1 kind of problem. That's where it's like, why are you measuring the head? Like if I have the basketball hoop and it's 10 feet high, and then I have a kid that's 3 feet tall, and I'm trying to find the distance from the kid to the top of the basketball hoop, I don't count the kid's head, like right here, that would be his head, as 1 foot, and then say it's 8 feet distance to the top of the. No, you don't count that. You count the one after it. That's going to become a kind of an issue with our naming conventions later. The wholes and half steps, of course, do that. There's the point that we're on. We're going 2 steps off of that point from the top of the head. I'm not including his head in the calculation. And then you get a half step, which is just 1 distance from the point, and then 2. A whole step is 2, whole step is 2, whole step is 2, and then half step to go back home. Now I've repeated that formula 2 times, so we can see this formula once again going around in a circle or infinitely going up and back if we want to see it from a linear perspective like a timeline. All right, so then if I name these, so here's where we start to get into it. So remember, as we do this, what's going to happen here is we're going to pull 7 notes. We're pulling 7 notes out of our baseline of 12. So the bottom of the pyramid, if you want to think about it as a pyramid, is our 12 notes. We're going to pull from it 7 notes. However, I can start not just on C, but on any of the notes. So that means for the collections of notes, how many could we have that we typically work with in Western music? You're going to have 12, right? Because I could do the same formula on any of these notes. So therefore, there's 12 collection of notes. In the following presentation, we're going to talk about the idea that you could then make each of those points the tonic, which we call modes, and there's going to be 7 different places that we could basically call a tonic. So that means scale-wise, notice how overwhelming this gets. People are going to talk about how many scales are there. Well, there's 12 times 7. That's going to end up to be a lot. But remember, that's too messy to think about, especially when you think in terms of a guitar, which you can basically see by shape. So basically, what does that mean practically? This big master shape, which we can cut up into 5 different shapes, or you can have 3 note per string shapes, whatever. It's all the same shape that we can then think about how to memorize and how we want to maneuver around it. This whole thing can be copied up and down 12 steps. So there's 12 of the same shape that can just move parallel up and down between the 12 notes on the fretboard. So it's all the same shape, right? And then within each shape, you can have any of the 7 notes as the tonic. So that means there's really only one master shape, which we break up into like different chunks. We break it up into 5 chunks. The pentatonic positions are 5 out of 7 notes, and then you can add the other 2 note. We can use the cage system, whatever you want to do, 3 notes per string. But it's all the same shape. It's just being shifted up and back. And then within each shape, you can apply the tonic to it. Any note could be the tonic. So that means you have 7 positions within the shape. Now, this is where it gets messy, though, because we're going to apply out a numbering system as we do this to a relative scale degree. Now, as we do this right now, it's all going to work because we're only going to be thinking in the key of C. As long as we only think of the key of C, we can apply this numbering system. So 1 through 7. And as I go through the 12 shapes, then that 1 through 7 will move up and back beautifully. Perfect. But when we start to go to another node within here, another mode within here, say the Aeolian, the minor key, then what happens scale-wise is they renumber the system and they make that the 1. That's what we want to avoid. That's what I'm going to say is the problem, right? That's the problem we have on the guitar, because we're going to resist wanting to do that, because I don't want to remember the same shape. I want to know all of these nodes in the shape intimately by the name that represents them most well music-wise. What is their name that represents them most well? Not the note name, not the relative position scale name, but the absolute modal name. Ionian, or call it mode number 1. Aeolian, or call it mode number 6. I want to keep those static. All right, so that's the problem we're going to come in now. As we do the scales and build these out, you're going to get overwhelmed and say, "Oh my goodness, there's 12 times 7 different shapes I have to learn." We're going to go over and show you all those scale shapes, but remember, no, that's not how it is, right? How it really is you're going to have to move one shape around and then see where the tonic is within that one shape wherever you're playing it. All right, so that's going to be the idea. So now we're going to say the formula. I'm going to apply it here in terms of the wholes and half steps for numbers: 2 2 1 2 2 2 1, and then we have the Roman numerals. Now the Roman numerals I just want to introduce here because that's kind of a shortcut to name the system, but it also gives us the capital and lowercase. And that allows us to give another layer of information. And typically that layer is going to tell us whether, if I build a chord off of these notes, whether it would be a major or minor chord. We'll get into more of that later, but I want to touch on it now because from a practical sense, that's what people typically learn first. So we're going to learn the notes in the scale, usually a C major first, and then we're going to learn that relative positions are 1 through 7. And then the next question is, well, I want to make chords. How do I make chords? Well, if you just make triad chords, all you really need to know is whether it's going to have a major third or a minor third, which you can indicate by the Roman numerals. I'm going to tell you right now that that's also a problem because I would like to know more than just does it make a major or minor chord, because this tends to make you feel like I'm moving shapes, right? So if I say the 1 is a major chord, the 4 is a major chord, and the 5 is a major chord, when I go in and build the shape over here, I'm thinking Ionian, which is the major chord, and then when I go over here, I'm thinking this is an Ionian major chord. See how that forces me to stop thinking of this as Mixolydian? It tells me to call that the 1. So it becomes a problem because it makes people visualize the guitar as they're moving through different shapes, but they're not. They're moving within one master shape. So I would like to at least address that, if not give a different numbering system. And you can accept that numbering system or not, but just recognize the issue so that you can memorize the fretboard as fast as possible, right? So this would be major, 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 1, 4, 5, kind of like the blues, and then minor, minor, minor. Now notice when I renumber the system, which we'll look at next time, for if I was to make this the root, like the 2 the root, what they would want to do is then call this the 1. So again, I don't want to call it the 1. I just want to say that I'm playing around the 2. Why? Because I already know the 2 is a minor. I already know the numbering system. If you renumber it, then I gotta remember which of the notes are major and minor, and that becomes a problem. Because why would I do that? That's more work that I don't need to. So then we have the notes. So these are going to be the notes in terms of the numbers, and then here's the note names. So this derives for us then, if I apply this formula out, you can see then clearly what happens if we're on the C. Notice that this 2 applies in between. So this is 2 from the C. So it's a little bit staggered the way it is, right? Because it's a 2 from the C, and then there's another 2 from the D, and so on and so forth. So if I count that out, then I get to these numbers, the note numbers, which is going to be 4 is a C, and then 4 plus this 2 is 6, and then 6 plus this 2 is 8, and then 8 plus this one half step is 9, 9 plus this 2 is 11, 11 plus this 2 is 13, right? Wait a second, it's 13. But there's only 12 notes in the musical alphabet. So whenever I get to something above 12, I would subtract 12, right? Because I'm going around in a circle. So you're going to say 12 and then back to 1. Or 13 minus 12 brings me back to 1. How would we do that in an Excel formula, by the way? We'll show you if you want to go do the Excel thing so you can build these tables efficiently. But then 1 plus 1 is going to give us the 3. Or I'm sorry, 1 plus 2 is going to give us the 3. And then 3 plus the 1 takes us around the circle again back to the 4. If we convert these numbers, see how useful it was to use the numbers there? If we convert those numbers, if we can code switch between numbers and letters in our mind, then of course we get the 4 is a C, the 6 is a D, the 8 is an E, the 9 is an F, the 11 is a G, the 1 is an A, and the 3 is a B. Okay, now in Excel, we will give you this worksheet so that you can change this 4 up top if you would like to. And then see, now that I've tested the concept, you can get other note names down here by changing it. So if I was in the key of D, we could just change that number and look at the notes basically in the key of D. I'm also mapping it out to the right. The reason I'd like to do that is because I'd like to compare sometimes, meaning maybe I want to compare the key of C side by side with the key of D or something like that. So I can build all of them to the right-hand side. So what I've done here, we just copied this over, the relative positions. Notice the beauty of this, how it maps in onto the fretboard. I'm copying this over and pasting it here. All the relative positions are shifting. That's exactly what happens on the fretboard. That Excel is the natural thing to practice. If you can think in spreadsheet, you're thinking fretboard, right? Because the same thing, if I just copy this whole thing and move it to the right, then that's how you shift from the key of playing in the key of C to the key of D or whatever you want to play. It's the same thing, same concept. We just copy this, we paste it over here. I'm going to change this to a 1. That's going to give me all the notes in A. How? Because an A is a 1. 1 plus 2 gives me 3. 3 plus 2 gives me 5. 5 plus 2 gives me 6. 6 plus 2 gives me 8. 8 plus 2 gives me 10. 10 plus 2 gives me 12. And then 1 brings me back to 1 because that would give me 13. Minus 12 gives me back to 1. And then if I copy and paste that over here again, we just copy and paste it just like we would on the fretboard. And we go, okay, now I'm going to make that a 2. So now we're going to start on a 2, which is A sharp or B flat, however you want to think about it. So we've got the 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 1 is 7. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 2 is 11, 12, 12, 13. 13 minus 12 gets us to 1. 1 plus the 1 half step brings us back around the circle to 2. And so on and so forth, right? So now we've got the 3 represents a B. And so same thing, we just copy and paste it for the 3, and we just do this all the way out. How many of them are there? There are 12. So notice, I notice when I'm watching like instructions on like a YouTube or something like that, that sometimes the tempting thing to do as a professional, as a musician, is to kind of try to, you almost have a drive to say, look how complex it is and I've mastered it kind of thing. And I get that because you have you're like proud that you've pulled it together, and that makes sense. But obviously the point here is to try to show how someone else could do it, right? You're trying to get it down to the baseline, simplest thing to understand. So if you say, hey, look at all these different scales, that's amazing. And I can play all of them, watch. And I break out my guitar and it's like, here's the scale, here I am playing in a G sharp and a G and then an A, and I can play. I've memorized all these, but that's more like a magic trick, right? Because what's really happening, the way you want to see it, is that although there's 12 scales that looks overwhelming, you can just shift the shape up just like we did with this Excel worksheet. I can tell you, look at this worksheet I built right here. It's amazing. Look at all that stuff. I built it out just for you. But it didn't take me that long because I just copied and pasted the shape all the way up the sheet, right? And then changed a few numbers on it, right? So you have to know how to do that. It's not like there's no skill involved in it. It's still hard to do. But I mean, I could try to oversell it, or I could try to be as transparent as possible and say, hey, I'll show you exactly how to do it, how much time it takes. And so, right. And so that's going to be the general idea. Now, of course, we could, let's go down here. What else did I do here? So notice that it could be useful to see these things side by side. Now, if you have this Excel worksheet in Excel, what you might want to do is see like this column only, right, next to this column so that I can compare these two. Or maybe I want to see this one over here next to this one. So this, in other words, this is too wide. How can I put them next to each other? Now, if you have these in Excel and they're all laid out to the right, you can just hide columns so that I can put these side by side. So if you watch through our presentation where we build it in Excel, even if you don't build it, you can then learn how to use this worksheet, right? You can learn how to hide columns to put the columns next to each other. And then I really think that if you have a well-designed worksheet that you're going to maximize your ability to kind of compare and contrast different scales by being able to hide cells and put things next to each other and try to figure out whatever you're trying to figure out, right? So here's, for example, the B next to the A sharp and the D, right? So then we can do things like that. So this is going to be the copying the formula down. So this is copying it down with a 3. So I changed the note name to a 3, and that's going to be the general idea. All right. So notice what we've done here on the major scale. We've used this formula to map out the major scale, not only in the key of C, but off of the 12 notes, which we see in a fretboard can be copied and pasted up. What we'll do next time is then think about the modes, which would be taking any of the notes in our collection of notes, making it the tonic, and then you can think about, well, that could give me 7 new positions. That's where the wonkiness comes in, by the way, for a guitarist and a piano player, by the way, because that's where the numbering system starts to change on scale degrees in a way that is not as efficient for memorizing the instrument. You can argue that it is efficient for writing music, composing and whatnot. In some instances, we can talk about that later, but I'm concerned with mastering the fretboard right now. And so we'll talk about that in future presentations.